In this particular session, we will be controlling a highly sensitive water level sensor that is capable of accurately measuring the precise height of the water. As you can clearly see here, there is indeed a water level sensor present, and it has centimeter markings on the back for easy reference. In a similar way, you can think of it as being quite similar to the soil moisture sensor that we worked with during our last session. We will be using this sensor, and just like in the previous session, we will utilize the ADC and connect it to the A3 pin, which is also known as the Y12 pin. So, please ensure that you connect the 3-pin cable to the Y12 pin in the exact same way as before. Also, make sure to connect the OLED display this time, and then proceed to plug in the module. Once you have completed these steps, you will be fully ready to proceed. I have already opened the code from our last session. Now I will just erase the code and try entering it again. To begin the process, you need to import the node into the system. This is a crucial step that involves passing a specific name identifier, which in this instance is 52136SKC. It's important to ensure that during this operation, the cache is completely ignored. Ignoring the cache is vital to prevent any potential conflicts or errors that could arise from outdated or incorrect data being used. Once the node is successfully imported, the next step is to execute a specific command, which is to play the SKC 168.649.1 address 063C. This command must be executed precisely, as it is a critical part of the process. Following the execution of this command, you must carefully check for and erase any spelling errors that might have occurred during the previous steps. This step is essential to maintain the integrity of the data and avoid any potential damage. After correcting any spelling errors, it is advisable to perform another erasure to ensure that no residual errors remain. Once these steps are completed, you need to set the water level accurately in the A3 pin. This requires a high level of precision to ensure that the system functions correctly and efficiently. Finally, while performing all these tasks, it is important to engage in the menu play. This is a repetitive action that helps in maintaining the system's stability and performance over time. By following these detailed steps, you ensure that the process is completed successfully and efficiently, maintaining the integrity and performance of the system. To begin this task, it is crucial to meticulously remove the text located in this specific section. This action must be executed with great care to ensure that the original lab area is left completely vacant. This initial step is of paramount importance, as it lays the groundwork for the subsequent instructions that will follow. Once you have successfully cleared the area, the next task involves replicating the lock that is positioned above. This lock is a vital component in the setup and must be displayed with a height of precisely 40 units. This measurement should match the previous configuration you have encountered, ensuring consistency and uniformity across all related components. Maintaining this uniformity is essential for the overall coherence and functionality of the system. Following this, you will need to undertake the conversion of the current measurement into a 16-bit voltage. This conversion process is technical and involves translating the existing data into a format that can be accurately represented within a 16-bit system. Once this conversion is complete, the voltage should be displayed with a high degree of precision, specifically up to the second decimal place. This level of detail is crucial to guarantee that the readings are both accurate and reliable, which is essential for the system's functionality. In situations where the value in this section falls below a specified threshold, it is important to recognize that it corresponds to particular measurements: 1 centimeter, 60 millimeters, or 55 millimeters. These measurements are intrinsically linked to the operation of the doorbell button, which is a pivotal component in this setup. Understanding the correlation between these values and the doorbell button is critical for troubleshooting and ensuring the system operates at its optimal performance. By meticulously following these comprehensive instructions, you will be able to complete the task successfully while preserving the system's integrity and functionality. This approach not only ensures the task is executed correctly, but also maintains the overall efficiency and reliability of the system. Each step in this process is designed to uphold the highest standards of precision and accuracy, which are fundamental to achieving the desired outcome. By adhering to these detailed guidelines, you will ensure that the system functions seamlessly and effectively, thereby achieving the intended result with confidence and precision. I have entered several values specifically 3 centimeters, 4 centimeters, and 5.5 centimeters into the system. Now, I am going to proceed by saving these entries. After saving, I will perform a thorough check to ensure that everything has been recorded correctly and that the values are accurately reflected in the system. This step is crucial to verify that the data input process has been completed successfully without any errors or omissions. It's currently in operation. As you can see, it says 0 centimeters. In this state, I will pour a little water. I need to pour the water and wait a bit, but it currently shows 1 centimeter. I'll pour some more now. After pouring water and waiting a bit, I poured more water and waited again, and now it shows 3 centimeters. This process involves carefully measuring and observing the changes in water level. Finally, when I pour water up to 4 centimeters, you can see that it is displayed as 4 centimeters, right? This demonstrates the accuracy of the measurement system. It's important to note that each step requires patience and precision to ensure the correct measurement is achieved. In this session, I controlled a water level sensor that can measure the height of water using CircuitPython. I will return with different content next time.